Now we want to talk about part three, which is the last part of rotational motion. Now we want to talk about application of rotational motion. The first one is what we want to look at two or three acceleration of a rotating body around the circular path. Number one is what we call the centripetal acceleration, which is what v square over r. We have what omega square r and omega v. That is what we call centripetal. Is an acceleration that acts toward the center that enable the body to move around or to rotate around the circular path. We have what they call the tangential acceleration, which is the part the body, if the part is toward the body, if this acceleration is not enough to hold the body, or the force acting towards the center is not enough to hold the body, the part which the body will fall through is what we call tangential acceleration, and is what is called alpha r. Now this is what alpha is angular what acceleration, r is what the radius of the circular part or rotating body. Then w is angular frequency, v is linear velocity. Now we have what they call total acceleration. Total acceleration is what can be written in form of what ACI plus what is going upward. Let's say this is positive y and this is positive x. So this one known ACJ if at all we want to write it. So total acceleration will now be equal to total. Let me write it as capital letter T. Total acceleration will now be what square root of what a c square plus what a t square. That is how to find the total acceleration, which let me complete it like this. Don't forget this is 90 degrees. So this is what how to this formula for total acceleration, which is tangential acceleration square plus centripetal acceleration square, square root of everything give us total acceleration. Now let's enter pulley. This is for what? For circular movement or rotating object. Rotating object. Now the second one I want to talk about is pulley system. Pulley system. Now which has an acceleration here. There is a torque tau given to us here. Now this tau, if the body is rotating like this now, don't forget that there is a tension up and there is a weight down. The weight is M1G, while the weight here is M2G. M1G and M2G. Now, if you want to consider the tension is upward, you want to analyze this one now. Look at the board. Now, what I want to do simply is what? Let's consider that this body is what? This one, for it to fall like this, it means that M1G is higher than tension. Don't forget that tension is going up. If some tension is going up, the body, the weight of the body on M1 is coming down. M1G. Tension is going up. So what we want to this for this part now, because the body is coming down, the motion of the body is downward. We check because this one we assume that M1 is greater than what M2 now. So it's higher than M2. So in that case now, what is the net force here? The net force will now be what? M1G minus tension. Let's call it T1. Let's call this one T2. T1 equal to what? M1A. Let's call that one is equation 1. It's 1. Then the opposite will happen. Because this one now, the acceleration is going down. This acceleration is what? Going up. Have it? So in that case now, for the second one, we are going to have it as what? Tension going up, the mass M2, then the weight M1, M2G. Now in this case now, since it's what? The body is going up, accelerating upward now. What will be our this? I would have tension is higher. T2, I call it T2, so I can differentiate this T1. So this T2. This is they have a couple system here. Minus what? M1 what? M2G, because we assume that tension, the one upward force here is greater than downward force. So upward minus downward equal to what? M2A. That's what I want to do. This one is equation 2, for instance. Now, I'm gotten that now. 1 and 2 have been set. Now, remember that what? T2. Now, let me clean this one first. This. Now, can I ask this? I'll see you draw it again. Now, T2 minus T1 times radius equal to torque. Please take note of that. T2 minus T1, that means because it's rotating like this now, you understand? We can take what? This T2 minus T1, because T2 is greater than T1 now. You check. Because this one is higher than this one now. If you check this one now, this one is bigger than this. For you to move upward, that is the one. So the bigger tension minus smaller tension times radius of the pulley. Radius of the pulley is this radius that will give us is equal to tau. Don't forget I told you tau is equal to F force times what? Times radius equal to tau torque. I gave it from the beginning of the course for part 1. So this force now in the pulley now is difference between T2 and T1. I told you T2 and T1 are not the same. So T2 minus T1 equal to tau over R. Make T2 and T1. Let's call this one equation 3. Now, if you now combine the two of them, let's add this equation 1 and 2 together. Let's add. We see something there. If you add it, I would have what? M1G minus T1 plus what? Add it to this one. T2 minus M2G equal to what? Add this two together also with the other side. M1A plus M2A. That's what I would have now. That's what I would have. We add these two together. Just click it the way they are. This one plus this plus this. So that we can now have what is common on both sides here. A is common. Abi? M1 plus what? Abi now? Now, what do we have now? Look at the board. I can bring this one close and say M2G minus what? M1G minus M2G. Abi? Then minus T1 plus T2. Now, look at the board. This one is what is common here? G. Abi? We should have M2 minus M1. Abi? What is common here? Let's say minus is bring minus as what you have T2 minus what? No. Yes, in other words, if you bring minus out, what do you have now? You bring minus out. That is T1 minus T2. Abi? Is it not true? That's what I would have. It's equal to what? A into bracket what? M1 plus M2. So in this case now, if I want to write, do the bracket, please. Now, if I want to make A something of formula, now from here, how the body rotating now? The pulley, is it rotating like this or like this? It's rotating like this. So if the pulley is rotating like this, it means that here should be T2, T1 minus T2. It's rotating in favor of what? In favor of what? Look at the pulley now. See, look at it. Look at it. Let me draw the pulley. Look at it. One is what? This is T2 or T1. This is what? T2. And this is R. Normally, T1, we assume that T1 and T2 are not equal here. That's why that is an assumption. Normally, the pulley system is supposed to be the same because they are rolling together. It's supposed to be the same. But we just assume so that we can be able to derive something out. So if you check this one now, is it not the same thing here? So it's the same thing here. So therefore, you can now have it as what? Class M2 minus M1. Something is wrong here. Let me see. M2. M1 is greater. Okay, this one is M1 minus M2. Okay. This one now is what? Okay, correct. So this one now M1 minus, because M1 is greater than M2 times G. Abi? Into bracket what? Minus what? What do you have here? E. That means in place of this one, can we place this one here? That means tau over R equal to A into bracket N1 plus M2. So finally, our A will now be equal to what? M2, M1 minus M2 times G minus tau over what? R divided by what? M1 plus M2. That is the common acceleration that will occur. Where C, that is what the torque in the pulley that will give us in what? Newton meter. R is what? The radius of pulley. So they will not give you tension, different tension. Don't expect them to give you. Most of the time, what they give you torque of this what pulley system, the torque of this pulley system and the radius. So with this one we can solve for the what common acceleration. So what we want to achieve in this pulley system is to find the common what acceleration eh, of a what of a pulley system. So this is what we want to solve. Now the third one, which is what third application, we have done first, we have done second, how to find acceleration, total acceleration, how to find common acceleration. Eh? The next one is to how to find acceleration in an inclined plane. In an inclined plane. How to find acceleration in an inclined plane. The one I drew before. Now, this is what we have here. We have the center, the way to be acting, mg. Now, this is normal reaction, R. Then the what? If you resolve here, now mg cos theta. You resolve it down. Then there is a what? A force downward, which is what? Mg sin theta. Then as the body is rotating down the inclined plane, there will be a frictional force backward. Don't forget this is what? A rough surface. Now, in this case, now we want to look at what? A body falling from a pulley system. Falling off from a pulley system. So now, if we want to calculate the body falling from a pulley system, what do we do? We say, let us considering along the plane, considering along the plane, the sum of forces is equal to zero. So what do we do now? This one must overcome this one because it's going down. So net force there will not be what? Mg sin theta minus frictional force equal to what? Ma. Now remember that frictional force Fr is equal to this is frictional force. Now, if I tau can be written here, torque here can be written as what? Fr times R. Fr, that is radius, what radius of the body times frictional force. Frictional force is always what? Along the what? This place. So let me put it here. It cannot be on the board on at the center, is that what? On the circle, because this is what is touching the ground. And frictional force is what? The friction that what? The opposite motion of the two bodies in contact. So it should be here. So if you want to calculate the tau here, it will be radius of the body from here to the center to the frictional force times friction. So this is tau now, which is what? Torque. And this torque can be written as what? What is torque? It can be written as I alpha. I told you before from the beginning of this course. That torque, which is representing force in rotational motion, is equal to F force times radius or I alpha. So what is I? You can write this I as what? Let's say if you multiply what? If you multiply this one by I, what will happen? Well, let me do something here. Let us assume this body is what? It's a solid cylinder. Let's assume it's a solid cylinder. You assume solid cylinder. Now what do we have? We have 1 over 2 m r square alpha equal to 1 over f r times r. What about if you assume solid sphere? This way you change o. I hope you know if you change different body, different formula. But before we do that, let me not waste our time concerning that. This one will now give us what? Half what? This one will now be n. We can write this like this. Look at the board. I want to maneuver alpha. This is r times r is what? R square. R times alpha is what? R times r square times alpha. But remember, this one means something, which is what? A equal to alpha r. Abi? Yes. A equal to alpha r. So in that, I can replace this one with A and turn it to what? Something like this. Look at the board. And turn it to something like, look at the board. And the what? F R R equal to what? 1 over 2 M what? R A. Or turn to that. Look at the board. 2020. So that this one now can now cancel this. So that means R N A is equal to friction now. So I will now take you back to this place formula now. So you now take it to this formula. Where is the formula now? The formula we started, which is 1. So I will now take it there. What am I going to do there now? Is to what? Is to what? Put it there. I would have mg sine theta minus na equal to ma. Let's make a the subject of formula, which I have mg sine theta is equal to what? Ma plus what? Half na. Have you? Is that not? So what will you have now? What I would have now will now be what? LCM is what? LCM is 2. 2 divided by M, you have 2MA plus what? 2 divided by 2, 1 times MA, you have MA. What to what? MG sine theta. So divide this one now be what? Give us 3MA over 2 equal to what? MG sine theta. So if you cross multiply, what do you have? We are going to have 2MG sine theta equal to 3MA. What do we do to make A solve the formula? Divide both sides by what? 3MA. So this one will cancel it. Abi? So that A is now what? 2G sine theta over what? Over 3. Now I want to give you assignment, those that are watching us now. This formula can be written, I can write this formula as A equal to what? Mg sine theta from this formula over I over R square plus N. This is general formula here. For that formula I just given now, you can write it this way. This one, like you put what? Any shape here can enter here. If you put for solid square, solid cylinder rather, if you put 1 over 2 mr square here, you are going to have that formula. To prove that we can prove this one for me, examiner, that we can arrive this formula from this proof I'm trying to give you from, can maneuver from here. How can you get to this point now? Prove it for me. Another thing again you have to note again is that don't forget this formula now, it can solve any shape. And if I put this one now, half look at it now. If I put what? A equal to mg sine theta all over what? This one now, solid square is what? Half mr square over r square plus m. R square will cancel r square. So 1 over 2m plus m give us 3 over 2m. Is mg sine theta over 3m over 2. This 2 will go up as what? 2mg sine theta over 3m. This one cancel. Is it not going to give us the same thing? So this is the general formula. So I can take any of the, depending on the rolling object. If the body that is rolling is sphere, 2 over 5 mr square. If it's a solid cylinder, 1 over 2 mr square. If it's a rod that is rolling about the center, 1 over 12 ml square. So it depends on the what? The case that you are talking about. But this one, if it's 1 over 12 ml square, this one will take L square, because it no longer be what religious spending, and so forth and so on. So that is the third word application. The last one. Now I want to look at number 4, the last application, which is the ratio of orbital angular momentum to the rotational or spin angular momentum. Now what I want to do now, let's say, let what? L orbital. This one be what? The orbital what? Angular what? Momentum is, I will need the calculator. Angular momentum of the earth, we take earth as a reference, orbiting the sun. Don't forget the earth is orbiting the sun. So the earth now that will orbit the sun in how many, what is the period of doing that? 365 days approximately. So period of doing that. Let's say what orbital momentum. You know that momentum, angular momentum is what? I times what? Times W, mass times velocity. So angular momentum is what? Mass times what? Velocity, which is what can be written as mr square w. Please take note of that. Now, what we're going to do now is what? We can say mass of the earth, since we are taking earth reference, radius square, orbiting radius. Now, that orbiting radius is about what? About 1.496 times 10 by 11 meter. That is what orbiting radius of the what? Of the earth around the sun. So times W or spin for orbiting what angular velocity. That is the formula for number one. Now where R is what? Orbiting radius is what that. Now we are left what? L of spin or rotational what? Angular what? Momentum be equal to this. And that is what this one is what? Rotational angular what? Momentum. So if that is what? The that one of what? Of the earth around it axis. Don't forget it takes what? What is the period of orbit? Take 365 days to orbit for the earth to orbit the sun. Now if how many days does it take for the earth to spin around the world? It's one day. A day will take it will take a day for the earth to spin around its axis. So take note of that. Then what is the what formula for that? Of what? Spin what? Angular momentum or rotational angular momentum is equal to mass of the earth, radius of the earth that we use to spin around it axis square times angular what of the spin. Now what I want to do now, they say we should find what is the ratio of orbital angular momentum to the rotational what angular momentum. That will give us what? Orbit spin angular momentum over what? L spin. So ratio now. We are going to have what? M what? Square W what? Orbital over what? Square angular of spin. Now that is it. So don't forget that in this case now, what we're going to do is simply what? Remember that this one can W is equal to what? 2 pi over T. So W of orbital or angular is what? 2 pi over T what? Orbital. Then similarly, W of spin is equal to what? 2 pi period of what? Spin. So if you substitute it here, this one will cancel this one. So we will have it as R squared. Now don't forget, there's a mistake here. This one is supposed to be what? 2, you take 2 over 5. That is factor, the ratio factor. The ratio momentum factor is what? 2 over 5. Don't forget the earth can spin what with 2 over 5. Check the moment of inertia that I gave you. The moment of inertia is what? Instead of what? Is 2 over 5 mr square for the earth to spin around the axis. So you are supposed to remove 2 over 5 here, please. So I will not make that mistake. Put 2 over 5 there. Then let's put all the parameters there. So we have cancelled that one. If you put this here and put this one here, there will be what we are going to be having is for L orbital angular velocity. L what? Angular velocity of the rotational angular velocity equal to what? R square over RE square times. Now this one will now go up because if you take what? 2 pi over t orbital divided by 2 pi over t spin. What do you have? This one will go up now. Now the 2 pi over t orbital times what? T spin over 2 pi. This now comes. So this one will now be t spin over t orbital. Because the other one has cancelled. So if you put the value there, let's substitute the value. The radius of the earth, the mean radius of the earth, RE is what? It's equal to 6.37 times 10 to the power 6. Is approximately 6400 kilometer. That we know in your longitude and latitude. So this one now be what? 6 to 1.496 times 10 to the power 11. Press the calculator for me. All square divided by what? 6.37 times radius of the earth all square times what is the T spin of the earth is for 1 day. And don't forget there is 2/5 here. Don't forget 2/5 here. Don't make that mistake. 2/5 is same thing as 0.4. Let me put it down. 0.4. That means the factor of the region in 2/5 from the moment of inertia of the earth. So that means 365 is the what? Period of orbiting of the sun around the earth. Where is it? Days. You don't need to convert it to a second because they will cancel out at the end of the day. So this one now we now have what? 0.4 here. So what is our answer here? Angular towards spin. This one will multiply this. So if you do the calculation, you are going to have what? 3.77 10 raised to the power 6 meter, which is approximately what? 3.8 times 10 raised to the power what? 6 meter. So that means the ratio of what? Of orbital angular velocity, angular frequency, or angular momentum rather, to what? To the spin or rotational angular momentum on the earth is what? 3.8 times 10 to the power 6 approximately. That's what you are going to have. 3.8 times 10 to the power 6 approximately. If you press your calculator effectively well, that's what you are going to have. And there are more applications, but major applications have been done. So you can try strive to ensure that you revise all these things. So when we shall see again, same time, same station, or same channel rather, I remain your humble presenter, Engineer. Please ensure you subscribe and like this video to encourage us to do more and to always see more of our video. We need encouragement from you. Please ensure you subscribe. If you are just watching my video for the first time and you are a returning viewer, ensure that you always watch my video. Thank you very much for watching. God bless you. Stay safe.